Okay, I'm going to work out some sample Lewis structure problems with you. The first one I'm going to do is regular salt. So if we take NaCl, first step we need to figure out how many total valence electrons there are in sodium chloride. So if we look on the periodic table, sodium has 1 valence electron, chlorine has 7. So to get our total number of valence electrons, we just add them together. So now we know that on our paper we should have 8 dots, 8 electrons. Second thing you have to do is you have to arrange your atoms. So we only have 2 atoms. Real easy, it's linear. We know that since chlorine is a nonmetal, it has to have access to 8 valence electrons. But if we look here, chlorine's only contributing 7. So if we draw in the 7 electrons that chlorine is contributing, and then we need to draw in the 1 electron that sodium has contributed. So now if we look at our structure, chlorine has access to 8 electrons. Sodium has access to 2 electrons, and these 2 electrons are in between sodium and chlorine, which tells us that they have formed a bond. Another way we can write this, we can use a dash between sodium and chlorine to represent our bond, but we still have to include the lone pair of electrons that are around chlorine. So this is a lone pair. So any electrons that are not part of a bond are called lone pair electrons. All right, so this is an ionic compound where we have a metal and a nonmetal. Metals do not have to have access to 8 valence electrons, but nonmetals do. All right, our next example, let's just do water. If we look on the periodic table, hydrogen has 1 valence electrons, but we have 2 hydrogens. And oxygen has 6 valence electrons, so we need a total of 8 electrons in our structure. We have to draw it out. We have to figure out what atom is going to be in the middle. What's our central atom? Typically the rule is whatever element's the least electronegative. However, hydrogen is an exception. Hydrogen only has 1 shell in its atom. It can only hold 2 electrons, so it can only form 1 bond. So we can't put hydrogen in the middle. So now we have to put oxygen in the center, and we'll put a hydrogen on each side. All right, so oxygen contributes 6 valence electrons. So 1, 2, 3, 4, 5, 6. Each hydrogen contributes 1 valence electrons. And we're going to put those valence electrons in the middle so that they can share them with oxygen. So we need to check, do we have 8 electrons around our nonmetals? So 2, 4, 6, 8. And then do we have 2 electrons in between our hydrogen and our nonmetal? So everything checks out. Another way we can draw this, we can use dashes instead of dots to show our bonds, but we still must include our lone pairs of electrons. All right, and then the last example I'm going to do for you is another covalent compound. It's carbon dioxide. So carbon has 4 valence electrons. Oxygen has 6 valence electrons, but there's 2 of them. So we have 16 electrons total in our structure. Now we have to decide, how do we lay this out? So we have 2 nonmetals. Carbon is the least electronegative between the 2, so it will become our central atom. And then we will put an oxygen on either side. So we like to be this as symmetrical as possible. So carbon contributes 4 electrons. Oxygen contributes 6. That dot ended up on top of another one. There we go. All right. We have a problem here. For one thing, each element, because they're nonmetals, they each have to have access to 8. They also have to be paired up. So we have some electrons that aren't paired, and none of our elements have access to 8 valence electrons. But we do have 16 total. What we're going to do is we're going to take those individual electrons and we're going to move them in between symbols so it can be part of a bond. So I'm going to take this electron above carbon and I'm going to move it here. So I'm going to erase it. And then I'm going to take this electron and move it to the center. So now essentially we have four electrons in between carbon and oxygen. We're going to do the same thing on this side. I'm going to take this electron underneath carbon and move it here. And then I'm going to take this electron beside oxygen and also move it to the center. Alright, so now we have 4 electrons in between each carbon and oxygen. That's called a double bond. And if we go through and count, we still only have 16 electrons, but each atom has access to 8. So our first oxygen has access to 4 in between oxygen and carbon, and then 2 on the top and 2 on the bottom. And then our carbon has access to 4 on each side. And then our last oxygen has access to 4 electrons in between carbon and oxygen, 2 electrons on top and 2 electrons on bottom. If we wanted to rewrite this, I'm sorry, I messed that one up. There we go. And make sure to include your lone pairs of electrons. And my smartboard is not wanting to draw dots today. There we go. So now we have 2 double bonds in our structure.